What's up, you guys? So we're looking at section 4.3. We're finding the least common denominator. And so this is just a background set of notes before we start adding fractions. Just the practice of finding what is that common denominator, because that's often a difficult step. So we know that to add or subtract two fractions, we need to first get a common denominator. So that's what goes in this blank. Annoying, it's not writing. And so we're going to look at just some number examples, then we'll look at some more advanced examples. And so here we've got 3 and 5. 3 and 5 are the denominators, and those numbers are relatively prime, meaning they don't have any common factors in them. In fact, 3 and 5 are both prime numbers. So the LCD, least common denominator, is going to be 15. And so remember, to get that 15, I multiply each fraction by a different number. So the denominator in the first fraction is 3, so I times top and bottom by 5, because 5 divided by 5 is equal to 1. So I'm not changing the value of the expression, and so that would be 10 over 15 plus, then 5 times 3 over 3, 9 over 15. Adding the numerators together but not the denominators, I get 19 over 15. And I can leave it as an improper fraction. I would want to reduce, but again, these two numbers don't have any common factors. 19 is prime. So when I look at an example like B, 8 and 10, well, they both have the common factor of 2. So of course there's the one way you could do it where it's like, okay, 8 is 2 times 2 times 2. You'd go to the prime factorization, and then 10 is equal to 2 times 5. So we need these 2's, and then we also need the 5. This 2 is going to count as that 2. Or we could just say, oh, I know that one of the multiples of 8 is 40, and 40 is also a multiple of 10. So to get that, I would times the first one by 5 over 5, but then I times the other one by 4 over 4. So I'm timesing by a different 1. And we do this to create the common denominator. And so we're going to end up doing the same type of thinking with our problems. This is just a refresher. So 25 over 40 minus 36 over 40, which yields negative 9 or 11. I think it's 11 over 40. Nice. And then here, example C, we've got a really fun one. It doesn't look like two fractions. So remember, in order to combine these, they need to have a common denominator, so they both do need to be fractions. So I write that denominator as 1. So I know that I just have to times this one by 15 over 15. So it's going to be 31 over 15. Ooh, 15 times 7. So it's going to be 70 plus 35. That's 105 over 15. I'm not going to do that subtraction in my head. 105 minus 31. I'm subtracting because they're opposite signs. And then I take the 5 and 1, I get 4. And a 10 take away 3 is 7. The 105 was negative, so it's actually negative 74. Even though the math that I think of is subtraction, it looks like I did 105 minus 31. I should change that. It was negative 105 plus 31, and we do subtraction to get that answer. So negative 74 over 15. Well, that was pretty fun. What was unique about every single one of these is that they were all numbers, okay? We had no variables, okay? Each time we found the LCD, and then we multiplied by a special fraction the number on the top and the bottom to get that LCD. So we looked to find the LCD, then we created the LCD with multiplication. These were all regular numbers. None of them were having variables, and none of them were binomials or trinomial denominators. So when I look at these next set of problems, I see that, well, they all have okay, at least in problem number 1, it already has a common denominator. So I don't need to do anything special on problem number 1 here. All I have to do is add the like terms in the numerator, keep that denominator the same. And so when I do that, okay, 7x and 3x, it's being added, so that makes 10x. 4 and negative 4, 0. So I've got 10x in the numerator, but x squared plus 3x plus 2 in the denominator. I don't need to do anything further. On number 2, I have 8, and then I have 8 times x. Okay. And so this number 2, I need an x over x in order for them to have a common denominator. So that'd be 5x minus 3 over 8x. And then on number 3, I have a 9 here, and I have a 3x. So I'll need to multiply both because my LCD is going to be 9 and x. Because the 3, I just need to multiply that by 3, and then it would become 9. So I times this by 3 over 3, this one by x over x, and then I have 4x plus 3 all over 9x. And then so on number 4, what's our LCD going to be? Well, they don't have anything in common, like 2 and 3 had some numbers in common, so that one would just be 7x. So that was really fun, a little bit of practice. So I times this one by 7 over 7, this one by x over x. Ooh, so I've got 14 over 7x, plus when I look here, I put parentheses around the numerator, and I'm going to use the distributive property to multiply to both terms. X times x is x squared. X times 1 is x. So this is over 7x. And now when I add these together, I get x squared plus x plus 14 all divided by 7x. And I can't simplify that further. So the steps are going to be to factor the denominators, and then that would include GCF factoring. And then you need to make sure that you have the common factors in both. You don't need duplicates, so like I didn't need to multiply 8 and 8 to get 64 on number 2. I just used the 8 twice. And on number 3, I didn't need it to be 27. I just needed it to be 9 because 9 was smaller than 27. So when I look at number 5, I'm going to look at those denominators. So we're not looking to actually figure this out. We're just focusing on figuring out that denominator. And then figuring out, well, what would I multiply to the first term and to the second term? So I can see that it's 2 and 14, so I take the 2 out and I have x plus 7. And then on the other side, I see 3 and 21, I'll take the 3 out, and again I have x plus 7. So this is super important. I need you to pay attention to this example specifically because it says there's this part here, which is called a binomial. A binomial is like a word, okay? It's like the word cat versus the 2, which is like the letter I. So cat, you can't separate any part of the word, and my students will often want to say, well, if I have x and then I have x plus 7, let's say I have x times x plus 7. These are the two denominators. I just need to times this one by 7. And that's going to give you 7x, not x plus 7, because this is a binomial. So whenever you see a plus sign or a minus sign between a letter and a number, you need to know, oh, that's a binomial. I can't separate it. I'll need that exact math phrase, that binomial, to be in the denominator. So here I've got the x plus 7. They both have that, so they already both have that. That's good. So my LCD is going to have x plus 7 for sure. So they both have that. And then I need the 2, and then I need the 3 also. So 2 times 3 is 6. So I'm looking for it to be 6 times x plus 7. Or 6x plus 42. Let's leave it in the factored form. So that means I need to multiply the first part by 3 over 3. And I need to multiply the second part by 2 over 2. And that's going to be a good answer. Now, number 6, I see the binomial m minus 1. So I put parentheses around it. And I see the binomial m plus 2. So I can tell, yeah, there's no GCF to pull out of them like there was in 5. And so my LCD needs the factors. I need the quantity m minus 1, and I need the quantity m plus 2. So that would be my LCD. So what does that mean? Well, that means I'm going to multiply the first part by m plus 2 over m plus 2, and depending on the numerator, I might need to FOIL. We don't need to distribute on the denominator. That means also on the other side, I would multiply top and bottom by the binomial that's missing. It has the m plus 2, so by m minus 1. So by that whole binomial expression, so this would be what's left over in the denominator, m minus 1 times m plus 2, not factored. Leave it in factored. I said not factored, not distributed. So let's take a look at number 7. This one's very exciting because I do see 2 binomials, but this is a special binomial. I notice the exponent is 2, so I believe I need to factor that further. It's not GCF factoring there. That's that difference of 2 squares pattern. So that's going to be b plus 3, b minus 3. And then here I've got 3, and then b plus, when I take out the 3, it's 4. So my LCD. Okay, so I need, this is the number, and then here's one binomial, a different binomial, and then a third different binomial. Since all of those binomials are different, I actually need all 3 of them to be in my LCD. And because there's just that plain number 3 on one of them, that needs to be in the LCD. Also, it needs to be in both denominators. So I need the 3, I need the b plus 3, I need the b minus 3, and I need the b plus 4. This would be a very hefty problem. Considering that I needed this entire expression, when I'm going to multiply, I would multiply by the b squared minus 9 on top and bottom. I factored it to see, hey, would the b plus 4 match one of these factors? In this case, it did not. So it would be easier when I'm doing the work to multiply by that expression b squared minus 9 than by b plus 3, b minus 3. Okay, so then here on number 7, I need to factor the denominators first to see what they've got. There might be a common factor between these, especially since this one has a 2 and this one has a 2. Maybe there's something to that. So I'm going to take a quick minute and factor those. I've got the 5 and the negative 6, so that's going to be 6 minus 1. So 2x squared plus 6x minus 1x minus 3. Then I do that fun fence. 2 times, and then I have x plus 3, and negative 1, x plus 3, 2x minus 1 is one of the binomial factors, and x plus 3 is the other factor. For the second side, I just cut it, and I can take out the x squared, and I have 2x minus 1, and I could take out a 5, I have 2x minus 1. I'm feeling good. I see this 2x minus 1. X squared plus 5. That doesn't factor any further. It's not the difference of 2 squares. In fact, 5 isn't a square at all. And so, okay, now I can see them all. So I've got the 2x minus 1 and the 2x minus 1. I only need that once in the denominator. I need the x plus 3. And I need the x squared plus 5. So this side is missing the x plus 3. And then this side is missing the x squared plus 5.